So let's move to the admittance chart. So we learned that in Smith chart we can represent reflection coefficient, right? Gamma, right? Basically, and then gamma real and gamma imaginary, right? So this round shaped circle with radius 1 represents the reflection coefficient in complex number, right? And then this number can be converted to G, right? GL, G in, something like this, any impedance, right? Easily. So we can call that impedance chart. Smith chart in impedance chart. And then this Smith chart also used as a admittance chart, so which is also useful. So let's understand. So in equation 244, we learned that G in from the input impedance of the transmission line with this length L, GL, so this is G in, right? G in can be represented as this mathematical form, right? So let's say L is lambda over 4. Then beta L is pi over 2, which is 90 degree. Then tangent beta L become infinite, right? So this term G in equal to G0, and this term will left, right? Because tangent beta L is infinite, so G0 and G. So G0 divided by GL left. So as we know, G in divided by G0 is normalized impedance, which is equal to G0 divided by GL, so which is 1 over GL divided by G0, right? So which means this is normalized Gn is equal to 1 over normalized GL. So if we think about admittance YL, if we divide by Y0, then we can say this is normalized YL. So YL, so YL is inverse of GL. Y0 is Y naught is inverse of G naught, so which is GL, right? 1 over GL, normalized GL, so this is Y normalized YL, right? So what does it mean? So lambda over 4 transmission line, lambda over 4 long transmission line provide a 180 degree shift in clockwise, right? Because we use lambda over 4 with this length, that means in Smith chart we have a 180 degree shift. Smith chart, right? So that means, so lambda over 4 transmission line shift means that impedance point changes to an admittance point. So let's draw Smith chart. So if we have Smith chart here, right? So let's say we have this is GL normalized GL, right? And then so let's say we have GL here, and if we apply L, which is lambda over 4 distance, right? Then what does it mean in Smith chart? Smith chart move to 180 degree to clockwise, right? Clockwise. The point over here. So this is GN, right? With this lambda over 4 long transmission line. But when this length is lambda over 4, normalized GN become YL. So this is admittance, right? So this become YL, right? Admittance of GL, right? So this is the meaning of admittance chart. So if we, let's say we have impedance point, and if we change 180 degree opposite side based on this origin, right, then this point represent admittance, normalized admittance, right? So which is 1 over GL. So let's have one example, right? So for example, let's say we have a GL is, normalized GL is 1 over J, right? So easily, right, to calculate the YL without knowing the Smith chart, this should be this relationship, right? So if we mathematically calculate, that would be, the value is 0.5 minus J 0.5, right? So let's see this is working. So GL, as you know, this is resistance chart 1, and then this is a resistance circle, and then this is a reactance circle, right? So this is 1 plus 1 and 1. So this YL is here, right? So if we find a point which is here, right? Point to opposite. So that will be here. So this point, right? So 180 degree shift, and then this is just opposite according to this kind of this origin, right? So if we read the value, right, so this is 0.5 and this is 0.5. So the value we read from here is 0.5, and this is 0.5. We put minus here because we read this is minus, right? So this is YL. So this is true, right? So from the calculation, we have this. In Smith chart, we just simply make this point to this way to here, and the point kind of indicate the value 0.5 minus J times 0.5, which is equal to this. So that means if we move this GL to opposite side here, then this value become admittance, normalized admittance, right? So from this knowledge, we can find admittance chart from this Smith chart we already learned. So this is Smith chart we learned, right? This is a constant resistance circle, right? And then this is a constant reactance circle, something like this, right? Because to convert this impedance to admittance, we just make it opposite, right? So we can define as this. So this is G is R plus, and then Y become G plus JB, right? So if we make opposite, then the resistance circle become this. So this become constant conductance chart. Constant G. This is constant R, right? This is constant G line, and then this one is constant B. This is constant B. Constant B. This is G. So this become admittance chart. So here we had this is inductive part, right? So X is positive and bottom is negative. So, right, so if X is positive here, so X is positive, right? Then equivalently here, this is B is negative, right? And then this part is B is positive. So this is X is positive. This is X is negative. X positive means B negative, right? So this become admittance chart. So this is the Smith chart, which include impedance chart, impedance R plus JX, and then also Y is G plus JB, right? G is conductance and B is susceptance. So here, blue circle, right? Blue circle, you are kind of, you know that this is a constant. The red circle here, right? Red circle is about impedance. So let's change the colors here. So you know that this circle, right? This circle is R1 circle, but is represented as a red, right? If you see this red, this one, right? This one is X is 1. This is X is minus 1. Right? So this is a resistance circle and reactance circle, right? And then here is a blue color one, right? So blue color one is kind of opposite based on the origin. So here, right? So red the blue circle. So which one is here? So this is G is 1, right? Normalized conductance. G is 1. So you can read the blue one. Right? So 1 is here, and as this blue circle becomes small like this, then G become larger, right? As the resistance become larger. So resistance value here is red, right? So you see resistance increases as this circle becomes smaller. So likewise, as this green circle, G circle is smaller, then this value become higher, right? So it makes sense. So So blue color means admittance chart, right? And then here, this is constant B circle, right? So this is, B is -1, because we said opposite. This is B is 1. So actually I gave you the example, right? So GL 1.1 1J, right? J1. So let's put this value. So how we can read this admittance chart? So let's say we have a point here, right? So 1.1. So in impedance chart, because 1 plus J, so we use red circle. So this is 1 resistance circle, and then this is reactance circle 1. So this point, right? This is YL. So to get the YL value, right? Because this chart includes this blue colored line, so that we can read YL immediately. So from this point, right? So we just kind of find the circle which intersect this point. So this kind of conductance chart, right? So this is 0.5, right? Blue one, 0.5. And then if you find this blue constant susceptance circle, so you see this one. So the blue one is 0.5, right? So because I said this is negative side for B, so minus J, 0.5. So this is YL, right? So this is same. This inverse of G, normalized GL is same as this. So through this impedance and admittance kind of a circle and line, then we can easily get GL and then YL. So I recommend you to understand all of the chart so that this will be very useful to find some circuit for the impedance matching later.